Okay, so let me first introduce quickly myself and Dimitra. We will be hosting this webinar for you today. So I'm Emilia Moreno Ruiz, and the Deputy Director of ecoinvent Association. I will be doing this webinar together with Dimitra Ioannidou. Some instructions we will send you, so you will receive the slides of the presentation. We will send them to you after the webinar. You will also have access to the recordings. The webinar is being recorded. We are doing a webinar today and the webinar tomorrow, so you will receive the recordings once they are ready and prepared to be shared. Then some instructions for after the webinar. You will receive a very small survey from ourselves. It will be very nice from you if you could fill it in and send it back, so we can understand how to improve and how to meet your needs and your requirements. And then instructions for during the webinar. As I have briefly said before, you're all muted. So if you have questions during the webinar, we kindly ask you to type them on the question section of the GoToWebinar app. We will be answering on the go during the webinar. We will be answering either also on writing, or we will take them out loud and then bring the question to the whole audience. If for whatever reason we don't have time to answer to a specific question, or it's considered too specific for the context of the webinar, we will try to answer to you by email as fast as we can. Okay, so that said, we can start. Let me start by introducing the team. Those are our faces, more or less. So on the structure of the webinar, we will start with an introduction, brief introduction to the association and the database. We will then give you the basics of the database structure, activities, and going into what transforming and market activities are. And then we will end up diving in the calculation of the database, diving into consumption mixes and supply chains, and then describing the system models, cut-off, APOS, and consequential. So let's start. It's me talking, Emilia Moreno Ruiz. So I will start with a very short introduction to the association and the database. So the ecoinvent Association is a non-for-profit association. Was founded in the late 90s by 5 Swiss research institutes and federal institutions. The team today is, we are more than 20. Most of us are technical experts in LCI or LCA, but we also have IT specialists and then a small dedicated team for sales and communication. Our main activity, and that's why you know us the most, relates to the ecoinvent database. We manage, we publish, we maintain, and we sell the ecoinvent database. But we also participate in other kind of projects. We participate in projects that aim at improving data availability and data quality. So we do that, for example, by supporting stakeholders in collecting, hosting, and publishing a lifecycle inventory data, or by helping them in creating tools and hosting those tools. A good example of that is the SRI project, which was not so far away, ended not so far away, Sustainable Recycling Industries, and which a lot of the results can be seen in the database, but also as a dedicated part of our website. And we also participate in projects which aim at pushing the boundaries of interoperability, so interconnectivity between formats, between databases. So we participate in the PEF initiative. We also participate at different levels in the GLAD initiative, the Global LCA Data Access Network by UNEP. So we are on the edge of interoperability. A few words on the ecoinvent database. The ecoinvent database is a global lifecycle inventory database. It's a background database which contains average data on the wide range of goods, services, and it contains today over 19,000 data sets representing about 3,200 products. It covers around 140 countries, and there's a new release every year. The data providers, they would come from all estamenta. They come from industry and industry associations, from research institutions and universities. There are also consultants or governmental agencies that will bring data to this database. The data, before being released, it goes through an internal review for compliancy and consistency, and also it goes through an external review by editors. This is a board of editors which are recognized actors and stakeholders in the different fields and sectors that will do this critical review of the data before it's published. And then, of course, around the database and its methodology, the association does user support, training, and capacity building, as this webinar that is putting all of us together today. Just quickly, the content of the database. The database covers all kinds of human activities, from crop production to electricity production, resource extraction, metal forming, transport, end-of-life processes. It's really, as I was mentioning before, a global coverage and covering as a big variety of sectors of the human activity. So, as I promised, it will be a short introduction. I would like now to give the floor. I will leave the floor to Dimitra. So, Dimitra, when you want. We cannot hear you on the, I don't know if you're muted.
Thank you, Emilia. Hello from my side as well. In this section of the webinar, I'm going to discuss about activities and more specifically about the two types of activities, transforming and market activities. What is an activity? In the ecoinvent database, an activity represents a human process of a human activity. Every activity produces a reference product. In addition to the reference product, an activity can produce one or more byproducts. An activity can have exchanges from and to the environment and from the technosphere. Exchanges from and to the environment are called elementary exchanges or elementary flows. Elementary flows are materials or energy entering the system being studied that have been drawn from the environment without previous human transformation, or materials or energy leaving the system that are released into the environment without subsequent human transformation. Intermediate exchanges are exchanges between activities from and to technosphere. Now, let's see some of the naming conventions in the ecoinvent database. The activity name contains the process name, which usually includes the terms production or construction or operation. Then we have further specification of the product. In this case, we have hard coal, and the geographical and temporal locations are specified in separate fields. In the case of treatment activities, production and supply mixes and markets, this characteristic is included in the activity name. As we mentioned before, an activity produces the reference product, and it can also produce one or more byproducts. The distinction between reference product and byproducts is activity specific. That means that the same activity can be, the same product can be a reference product of one activity and a byproduct of another activity. In addition here, I would like to mention that there is a dissociation between the process and the outcome of the process, which is the product. And this is important because in this way we can create consumption mixes for all products. That means that products can be produced through many different activities. The activities, some of the characteristics of the activities are that they can exist for different geographies. And also we can have activities producing the same reference product, but through different technologies. For example, here through hard coal and through hydro pumped storage. In the ecoinvent database, we have defined some regions for the activities. We have a global scale, a continental scale, we have the country level, we have states or regions inside the countries, for example, states in Brazil, and we also have specific regions. For example, these are the regions used in the aluminum industry. Until now, I discussed more about transforming activities, but now let's see an overview of all the types of activities in the ecoinvent database. We have transforming and transfer or market activities. And in both cases, activities related to waste treatment are a different category due to the different modeling assumptions followed. A transforming treatment activity is a transforming activity with a reference product that has a negative sign. And the reason why we have a negative sign is that it represents that the activity is applying the service of treating or disposing of the reference product. For example, here we have the activity treatment of waste paperboard, municipal incineration in Switzerland, and the reference product is -1 kilogram of waste paperboard. If we exclude the reference product, all the other exchanges in the treatment activity are like in an ordinary transforming activity. That means the inputs and outputs from and to technosphere and the environment are also present here. In addition, and this is something that Emilia will explain further afterwards, a transforming activity with a waste output, which is normally represented as a normal output in the undefined model. In the linked system model, it is represented as a negative input, and this allows to maintain mass balance within the inventory. To better understand this, let us see how the treatment activity works with the waste producing activity. So we have the output of waste paperboard in this activity that is modeled as a negative input, and in the treatment activity, the input is modeled as a negative reference product, which represents the fact that it's treated or disposed of. This way of constructing the inventories allows mass balance. We mentioned before that there are two types of activities in the ecoinvent database. There are the transforming and the transferring activities. Up to now, we focused on the transforming activities. Now let's see the market activities. Market activities are consumption mixes. They provide products from producing activities to the consuming activities that use them as inputs. For example, in this diagram, we see the market for electricity high voltage that is applied from two activities with electricity high voltage, and the reference product of this market is again electricity high voltage. Some of the characteristics of the market activities are that they represent consumption mixes. Imports and exports are reflected in the consumption mixes. In addition, markets add information related to the transport of the product, and also they provide information about losses. And in addition, each product has at least a global market, and markets for a product cannot have overlapping geographies. So here we see what I mentioned just in the previous slide, that the market can have information about emissions, about transportation and losses. And here, this is a screenshot from EcoQuery. This is the ecoinvent platform for accessing the database. This is an extract from the activity Market for Electricity High Voltage. The market has as a reference product 1 kilowatt hour of electricity high voltage. We can see here we have from Technosphere different inputs. These are here we have the activities supplying the market. For example, electricity production, hydro, runoff water produces electricity high voltage that is then supplied into the market. And in addition, we have information about transportation and about emissions. In the transforming activities, we discussed about waste treatment activities. And in a similar way, we have here as well markets for waste. These markets represent a consumption mix of the waste treatment, and they also have transport information. For example, let's assume that municipal solid waste can be incinerated or landfilled. These two waste treatment activities, incineration and landfill, will supply with a negative sign the market for municipal solid waste. The reference product is here as well negative. And similarly to the normal markets, markets for waste refer to a specific geography and represent a specific product. Like any other activity, markets also can have different geographies. That's the reason why we can have different markets for the same product. In addition, we can have market groups. Market groups are datasets which combine markets of smaller geographic areas into a bigger one. For example, market group for electricity, Europe, is composed of the market, here market for diesel. Europe is composed of the market for diesel in Switzerland and the market for diesel in Europe without Switzerland. One more aspect about related to the geographies. The geographical coverage is important in the ecoinvent database because the supply chain is established based on the geographical localization of the market, the supplying and the consuming activities. This means that in the linking of the datasets in the linked system models, the geography of the supplying and the demanding activities is taken into account for the linking. Geographical coverage has been completed through the introduction of the global datasets. That means that each transforming activity has a global counterpart and each product has at least a global market. A geography that is very often encountered in the database is the rest of the world. Rest of the world is an area in the ecoinvent database. Datasets for rest of the world contain data for all geographies which are not individually represented in the ecoinvent database. For example, let's see here the activity coffee green bean production Arabica. The ecoinvent database includes datasets for this activity for Honduras, Colombia, Brazil, and India. The rest of the world geography, in this case, covers all other countries or territories outside these four. It is calculated if the available non-global geographies are deducted from the global geography. Another example is the activity cement production Portland. In this case, the database covers individual geographies of India, Brazil, Quebec and Canada, US, Peru, Switzerland, Europe without Switzerland, and South Africa. In this example, the rest of the world geography is different than before. And finally, summarizing this part, some key points to retain are that the database is organized in activities representing manufacturing, fabrication, production, construction, or extraction of products. Several activities, different geographies or technologies can produce the same product, and waste treatment transforming activities and markets have a negative reference product. Thank you from my side, and now Emilia.
Yeah, thank you, Dimitra. Before jumping on my part, there is maybe a question and some remarks that we received. I can take them here because it makes sense. Some people have been asking how can we access and see which products are available in the ecoinvent database, for example, also related to how to see in which geographies those activities are happening, and like now Dimitra was explaining. So I would invite you to check the most recent webinar we did before that one, which is called Q&A, and there's a whole part on it's live demonstration on how to find all the possible files that the ecoinvent association prepares to help you navigate the content of the database and the database itself. So there you will have an eye on, okay, what is the activity overview, what information is there, and what can I find, how to see what products are available, what activities, what technologies, what geographies, how to find the matrices, the database represented in different formats. So I would recommend you to watch that webinar and, of course, come back to us and write to us in support if you still have more questions, for sure. So, thank you. And I then jump to the final part of the webinar, where I would like to dive a bit on how the database is calculated using consumption mixes, how the supply chains are structured, and then go into system models a little bit. So let's start by understanding together how the supply chains are structured in the ecoinvent database. Dimitra has already been giving us a lot of elements for that. She has explained what are the transforming activities, what are the markets. She already gave a first hint on how those two structure together and how they form the supply chains when she was giving an overview on the geographies. So let's go a bit in details here. The linking of the supply chains will be always structured and organized around the markets in principle. So these supply chains will be then structured around the geographical boundaries of the market. As Dimitra has mentioned, there will exist always at least one global market per product. But of course, there are regional markets that will exist when it's necessary and it does make sense. And in any case, it is important to retain it's around the geographical boundaries of the market that the consumption mix is structured. So is the producers that are going to supply these markets, these producers of the same product that are represented different technologies, will be selected because they are in a matching geographical area, and an area that matches the market geographical boundaries. So that's how the market will be supplied, and the consuming activities of the product that it's supplied by the market, those consuming activities that are getting inputs from the market, they are also located in a geographical area which is matching the geographical area of the market. There's an important consideration to be taken into account, is that there is always the possibility of adding a direct link between producers and consumers instead of using the consumption mixes. This is something that can be done by the author of a dataset. When a dataset is integrated in the ecoinvent database, there is a choice. It's the choice of the author to select during the creation of the data and the submission process whether the supply of a given input comes from the general consumption mix or from a specific supplier, a specific technology. For you as users, for your foreground system, you of course have always the choice to use the consumption mix, so the market, or a specific supplier, a specific technology for your system. When you are choosing a specific supplier, things like transport or losses that are covered by the market, as Dimitra has been explaining to us, they need to be then taken into account by the transforming activity consuming the product, of course. Let's maybe visualize an example of a supply chain. We can use this market for electricity in France, and here you can see that the main technologies contributing to the market are represented. They are represented with specific shares, as you can see. I can maybe also use a pointer. So as you can see, they are represented with specific shares. And those shares are, they have been calculated based on the relative production volume, so how much product is produced in a year per each of these technologies, relative to the overall production volume of electricity high voltage, which is made available overall in France. As I was mentioning, I'm representing here the main suppliers, because as you can see, this adds up to around 90% of the total market. And of course, the total market shares, they always go up to 100%. So I'm also representing here, it's a very small supply chain. I'm representing a consumer, which is the transport passenger train in France, which is receiving inputs from this grid, from this market for electricity high voltage in France. But maybe we can imagine an example using this very similar supply chain, where the addition of an activity link, a direct link between a and consumer would make sense, and is actually used in the database. So if we think about the electricity production in the aluminum industry, there is the need of specifying the technology that will be feeding this electricity production dedicated to the aluminum industry. There is the need of setting a direct link from a technology, in this case is nuclear, that needs to be supplying the dedicated technology of nuclear electricity production with nuclear technology for the aluminum industry. In that case, as you can see, the consumption mix is not used, and instead this is this direct link setting the two activities together. So just to wrap up this very first introduction, the market will link together producing and consuming activities in the geographical boundaries that the markets describe. As much as needed, the consumers can link to specific suppliers of a product instead of to markets within the database context. And of course, as a user, you can always choose between the outcome of the supplying activities, so specific technologies, or the consumption mix, the market for your foreground system. Okay, let's dive now then into the database structure a little bit. And the first key concept that I would like you to retain is that the ecoinvent database is developed and maintained as a collection of multi-output unallocated and linked uniprocesses, gate-to-gate processes. This is a collection of markets and transforming activities, like Dimitra has been explaining and describing to you. Those unit processes are created and maintained in a form where they are representing closely the reality. They are created in a form where the wastes are modeled on the output side of the activity. Those activities will have several co-products, if of course this is appropriated. There is a full list of inputs that will be linking to the specific suppliers already if this has been considered necessary, as we have been seeing just now, or will not be linked to anything if what it's expected is a linking to the consumption mix, to the market. So that collection of activities is the undefined database. The undefined database is only accessible through the ecoquery. Ecoquery is the portal to have access to the ecoinvent database through the ecoinvent website. And you can use this version of the database, this undefined version of the database, to check the modeling of each activity, the choices that were taken, and then also to check the balances, mass balance, carbon, and water balance. So this version is the version that it's used to build on top of it, or calculating with this version, the three system models that you know, which are allocation cut-off by classification, allocation APOS, and substitution consequential long-term. So for that, what will be used are different algorithms that will reflect different modeling options, and they will be applied over the same initial undefined database. We can see the same thing, but now with a scheme. So first thing, let's go back to the beginning. This is the undefined database, this collection of multi-output and unlinked uniprocesses. Everything is based on this undefined database. To this undefined database, there is a series of distinct linking rules that will be applied. So the linking rules is not a black box, it's not something magical, it's simply a collection of rules that will allow the calculation of different versions of the databases. And for that, they will be using different distinct modeling choices. So the typical problems that these linking rules will be addressing relate to how to solve multifunctionality, how to solve the allocation problem, how to deal with recycling and waste streams, how to handle constraint in suppliers. So all those linking rules are then written and formalized in what we call an algorithm. So we have three different linking algorithms that will calculate from the same undefined database three distinct databases. So at first, they will calculate the supply chains and consumption mixes, etc., and calculate single output linked uniprocess. And on top of that, LCI and LCIA results will be calculated. So this collection of single output linked uniprocess, LCI and LCIA results, each of them is called a system model. Now they are called here in this slide X, Y, and Z, but you can give them names because you know them. This is cut-off, APOS, and consequential long-term. So there are initiatives, for example, like Ocelot, that will allow you, if you are a user that can handle these type of tools, to code for your own algorithm, use undefined, and create your own system model, which will be then reflecting the modeling choices, options that you wish or that you envision for your project. So let's maybe now explore together the modeling choices that make each system model distinct and different. So the first difference between the system models relates to, of course, the way byproducts are handled, the way multifunctionality is solved. We have two system models that will apply allocation, partitioning. This is allocation cut-off by classification and allocation APOS. And here the burdens are shared, burdens are partitioned between co-products of the same activity to solve this multifunctionality. For that, allocation keys, allocation factors are used. We have another system model, which is substitution, consequential, long-term, that applies substitution. What does it mean? It means that the reference product for the activity is the one that is burdened with the full impacts of all inputs and emissions of the activity, but at the same time, it also receives credits if there are byproducts in the activity, because those byproducts can substitute other primary production, and for that, credits are given to the reference product. The second difference among system models relates to the way burdens for waste treatments are considered. So in general, ecoinvent will give responsibility to the producer of the waste, and the burdens are carried by the producer of the waste. That's the case of allocation, cut-off by classification, and substitution, consequential, long-term, with this exception or with the nuance that recyclable materials will be provided burden-free and will be disposed and treated burden-free in the allocation cut-off by classification. In the case of APOS, the burdens which are associated to the treatment of the waste will be shared between all possible valuable products which are appearing or which are generated in the value chain. So the burdens in the end will be shared between the producer of the waste and eventually those that are making use of the useful treatment, the useful products issued from the treatment of the waste. And there is a third difference, which is the way the consumption mixes are supplied. That's how I started this final part of the webinar, how consumption mixes are supplied. So in the case of allocation cut-off by classification and allocation APOS, all suppliers within the boundaries of the market will supply the market, will supply the consumption mix. This is what's called the average suppliers approach. In the case of substitution, consequential, long-term, only the suppliers that can adapt to changes in demand supply the consumption mix. Those are called marginal or unconstrained suppliers, and only those that are within the boundaries of the market, of course, only those supply the consumption mix, the market. So you can see already with this very schematic representation that the market composition is different in the attributional or in the consequential approach. Okay, so let's go into a bit of details of the three system models. I will start with allocation cut-off by classification. This is the system model that we more often advise for beginners, for people using ecoinvent database for the first time, also for people which want to have a continuity with the version 2 approach and version 2 modeling choices and options. This is the system model that suits those needs or those requirements. So it's called cutoff, but the cutoff doesn't happen within the activity. That's how it used to happen in version 2. That's maybe a first difference. All co-products in the version, in the ecoinvent database, in the version 3, all co-products are considered and inventoried in the activities. So the cutoff happens because the products are classified, and because of this classification, they are allocated or treated differently depending on that classification. This classification is given by the author of the dataset and by ecoinvent, and it's then reviewed by the corresponding editor because it determines the results that will be obtained, of course, for that product. So how is then the system using this information? So First, if we imagine this example where we have an activity that it's generating products that are classified as allocatable, and then a product classified as waste and a product classified as recyclable material. How is this then being handled? Well, the first thing is that products that are classified as wastes or recyclable materials, as Dimitra was also showing when she was showing treatment activities and supply of those treatment activities. Those products classified as waste or recyclable materials are moved to the input side with a negative sign. So just a reminder, this is maintaining mass balance, and this is then just allowing the construction of the supply chain properly. The allocatable products, here in this case product A and B, they stay in the output side. So what happens to the allocatable byproducts? Let's take that first. Just as a remark, most products in the database are classified as allocatable. So this is 90% of the products in the database. You can think of them the more often as the valuable byproducts. They are then, as we were mentioned, allocated directly against the reference product and eventually other allocatable byproducts. How do we do allocation? This is now mentioned here in the, let's say, under the umbrella of cut-off system model, but it's of course also it's valid for the APOS system model. Allocation in the ecoinvent database happens following the ISO 1440 and 44 hierarchy. First, what it's tried, it's a subdivision of the system, so a disaggregation when possible. Second, physical relationships, when this is feasible and available. A very good example is exergy, used as an allocation key in datasets that co-produce electricity and heat. Generally, when physical relationships or subdivision are not possible, economic consideration is used. So price is then used to allocate. Mass allocation is almost not existent in the ecoinvent database. Something I wanted to show you now quickly is where to find the allocation factors and the allocation key, because it seems that this is something that we have made harder for our users. We apologize. This is a screenshot of a dataset or two datasets accessed through the ecoquery. As I said again, the ecoquery is this portal that allows you to have access to the ecoinvent database through the ecoinvent website. These are tuna captured by pure purse seiner and landing hole frozen, and it produces two products, so small pelagic fish fresh and landed tuna frozen EPO. As you can see, we are looking here at the properties of those products. Properties is something that it's not visible in any software tool. So this is maybe another of the reasons why a tool in ecoquery might be interesting. There's a lot of features that the ecoinvent database supports and offers that are not supported by the software tools, and properties are one of them. So true value here, this is the allocation. It is giving you and allows you to calculate the allocation key. It's here and here. Sorry, here, yes. So this true value is it's already taking into account the relative amounts of the two products and the price, and it helps you calculate that the allocation key is actually 96 for the tuna and 4% for the small pelagic fish. Okay, let's go back to the other two categories of products, wastes and recyclable materials. Let's see how they are handled by the system model. So we can we go back to our example where, in that case, we have one reference product here and a product classified as waste and a product classified as a recyclable material as negative inputs here. So let's start with the recyclable material. Just as an information, only 2% of products in the database are recyclable material. And how are they handled in the cutoff system model, they are provided burden-free to demanding activities by a dataset containing no inputs or outputs besides the recyclable material itself. These are those activities called recycled content cutoff, and they are empty. They are representing and making real this point of cutoff. So the disposal of recyclable material is burden-free for this activity. The further use of this recyclable material is burden-free as well. In the case of recycling chains, this point of cutoff, this first provision of the material burden-free, happens in the first step of the chain. And what about wastes? Wastes are around 8% of the products in the database. And in that case, the activity will get the full burdens of treating the wastes. But if they are any valuable byproduct that it's produced out of the treatment of this waste, this will be also delivered burden-free as well. This is another point of cutoff here. This valuable byproduct will not give credit to the system in any place or by any means. So let's wrap up. Yeah.
Emilia, maybe I could shortly interrupt you. We have also a question related to waste treatment and whether markets for waste treatment are equivalent to waste scenarios in the previous ecoinvent versions.
So markets for waste treatment, as I can go back here maybe, well, it's not very useful, but markets for waste treatment is, as Dimitra was explaining very well, the concept is the same as a market for a regular product. They will provide the user with the technology mix of the different disposal options that the waste has in a given geography. So if we imagine a waste like municipal solid waste, which I'm going to use later also as an example, it can be treated by incineration or landfilling. In some geographies, we will have open burning or open dumping. The market for the geography will contain a representation, a mix that will cover those technologies in the appropriate amounts, so representing the appropriate shares for those technologies in the given geography. So you can picture them as, in the end, it's not very different, or it's not different at all from the market for regular products, but they are considering the different treatment options. So, okay. So as I was, let's maybe wrap up quickly the cutoff, and then this allows me also to jump into APOS as opposed to cutoff. So I think we will be able then to compare the two in a nice way. So cutoff system model is separating primary and secondary use phases very well. The burdens of primary production will stay with the first use of the product, and they are not going to the secondary use of the product. As you can see here in this example with aluminium, the aluminium scrap will come burden-free, creating a clear separation between primary and secondary uses. The use of secondary materials is incentivized because there's no burden given for recyclable materials, so for the scrap. But in return, there's also no credits that are given to useful products in the waste treatments. There is the full burdens are given to the waste producer. So in a way, there's no incentivation to explore treatment technologies for waste that will generate more valuable products along the chain, because there's no credit for recycling or waste for byproducts produced during recycling or waste treatments. Let's look at APOS now. APOS is different. APOS has a different approach. So in APOS, the impact of an activity that is generating the waste that needs to be treated. So this is this blue a square. This is an activity generating a product A, and then a waste that needs to be treated. So the impacts of the activity that is generating the waste to be treated and the impacts of the activity of treating the waste, which is then this pink thing, are shared, are combined, are shared together between all commercial products produced in the value chain. In this case, it will be product A and product E. The value chain might contain a treatment chain and potentially several commercial byproducts. This here is a very simple example. Well, all impacts in the end will be considered together and allocated within all those valuable products in the value chain. What are the consequences of that? Well, in APOS, waste producers are incentivized to assess recycling and reuse possibilities due to this partial allocation of impacts to useful treatment products. On the other hand, as you can see here, there's not an incentivization of the use of secondary materials per se. There's not such a distinction between a recyclable material and a waste or something like you can find in Cut-Off. I would like to go a little bit more into the details. I draw a very simple value chain and I would like to explore how it works in APOS. So here we have just an anonymous transforming activity, which is generating a product A and also generates municipal solid waste. As we have seen before, this is moved to the input side with a negative sign and mass balance are preserved. This municipal solid waste will then get treated by a treatment through the market by eventually different treatment activities. For reasons to keep everything simple, I have just added one of the possible municipal solid waste treatment activities, of course. Let's imagine this is incineration. So incineration will incinerate the municipal solid waste and will, of course, then also generate heat and electricity. So how is allocation going to happen in allocation at the point of substitution? Well, it will happen at the point of substitution. And where is that? That's here. The point of substitution is the point where the first, let's say, commercially valuable product appears in the value chain. So this is here, this transforming activity. So we have done this small system expansion. We are considering this system as a whole. And what's going to happen is that this valuable product, which we can picture is heat or electricity from incineration, it's going to be moved here and it's going to be allocated here. Here it's where allocation will happen. That means that this transforming activity will have now all the burdens allocated between this product A and this product C, as I was saying, heat or electricity from incineration of municipal solid waste. So the burdens of treating the municipal solid waste are now shared between two activities. As you can picture, we have in the database hundreds or thousands of activities which are generating municipal solid waste. So in theory, you might have hundreds of individual data sets where this electricity have been allocated to. So we will not provide to you all those individual data sets. Instead, what happens is that the weighted average is calculated, and this is an average of the burdens of this electricity production from municipal solid waste incineration according to where this waste has been generated in the database. These data sets can be very hard to read. They might contain a lot of inputs. They might represent a mix of a lot of diverse supply chains. If we picture waste like municipal solid waste or of bio-waste, you can imagine that the number of value chains where they are involved is potentially very high. So this will generate those data sets, which in APOS might be very hard to interpret. Okay, So let's address, I propose we address substitution, consequential, long-term system model, and in the end we can do a wrap-up of the three system models together. Well, in the substitution, consequential, long-term system model, yeah, substitution is used to resolve multifunctionality, of course. That means that byproducts are there they are replacing a primary production. They will get the credits for it. So as I have said before, the reference product of an activity is burdened with full impacts of the activity, while also credited with the benefits of these primary production activities that can be replaced by the byproducts. In consequential, you will only see the activity producing the reference product, the main product. The byproducts will be all byproducts. There's no distinction here between the waste or wherever. All byproducts will be inputs to that activity. So mass balance are always preserved. Maybe we can visualize that. This is a screenshot of a PDF report. PDF reports are another interesting feature that you can use from the ecoinvent database. If you're using ecoinvent in an LCA software tool, when exploring a data set, you might find URLs, links to ecoinvent. Those links are directing you to those PDFs. Those PDFs, this is just a small screenshot. You can download them. You have full meta information on the data set, and you have a lot of information that you might not see directly in the software tool. So if we look here, we are looking at wheat production organic. We can see here, this is the wheat grain organic. This is the reference product. And here we can see that straw organic, which was the byproduct, has been moved, and it's giving the credit, has been moved to the input side with a negative sign. Okay, another aspect of the consequential system model is that only unconstrained suppliers are taken into account. Who are those unconstrained suppliers? What does this mean? Okay, the unconstrained suppliers, also called the marginal suppliers, are those who can respond to changes in demand by adapting their production. So first of all are those that produce the product as a reference product. We have seen byproducts are moved to the input side. So first of all are those that produce the product as a reference product. Only those are supplying the markets. And then are those that represent the technologies that are more suitable to adapt to a change. Let's see that a bit in detail. So there's this aspect of marginal suppliers which lies on their capacity to adapt to the political or the regulatory or the economic landscape and to supply the product as the demand grows in a growing market. And this in the ecoinvent database is done through the technology level, which is a tag. It's a tag that sets the activity as outdated, old, current, modern, and new, and that labels which of the technologies are able to adapt and provide additional capacity in a growing market, in a growing demand. So in the case of a growing demand, it's a new or modern technologies, we will be able to adapt and to increase capacities to adapt to that change. And then, of course, as I was mentioned in the beginning, this is the constraint set on the byproduct. If we have this example here, I just set example around meat. So we see here the production of meat. In the case of the sheep production for wool, the production of meat is constrained when meat is a byproduct. Only the activities that produce meat as reference product are unconstrained. So only those are supplying the market. Only those are able to adapt to changes in demand. Only those are suppliers, unconstrained. The marginal suppliers are those. And as we have seen, the byproducts, or the meat here, in the case of the sheep production, is moved to the input side, changing the sign to maintain mass balance. And as I was saying, it cannot supply the market and is constrained. Instead, this negative input, it's bringing the credits to the activity, to the sheep production for wool, is giving credits to the wool product for avoided primary production. In this case, for reducing the need of meat from the meat producers. So in that case, the fact of having this as a negative input, mismatching with this, which is a positive output, it's what allows us to give those credits to through the byproducts to the reference products in the consequential system model. And finally, it also happens that all suppliers are constrained. So that happens when byproducts cannot be substituted by primary production. That happens when a product is exclusively produced as a byproduct, but still it has a demand. It is commercially valuable. An example is sodium hydroxide. Sodium hydroxide is a byproduct of always of chlorine production, but of course it has a demand. It has a market for itself. So in that case, the use of sodium hydroxide will lead not to, of course, it cannot drive an increase in the chlorine production, but it will lead to a reduction of the use of sodium hydroxide somewhere else. And this somewhere else is what we call the marginal consumption activity. So we cannot have a marginal supplier, we need to have a marginal consumer. This marginal consumer is the one that will be able to switch to an alternative mean of production, liberating then sodium hydroxide to be used elsewhere. That's where substitution will happen through the activation of this marginal consumption activity. Okay, and I would like now then to wrap up and give some ideas around all system models. So first, let's repeat some things we have said and let's try to compare system models together. First, the cut-off system model will separate primary and secondary use stages. The approach incentivizes the use of secondary materials, as we have seen, but it does not incentivize waste producers to maximize reuse of waste materials. There are no benefits given to useful treatment products or useful products out of recycling activities. On the other hand, APOS waste producers are incentivized to assess recycling and reuse possibilities due to this partial allocation of impacts through the value chain. So APOS can, for example, be used in studies where the question of waste or disposal or recycling is a topic, can be used as a counterpoint to the cut-off system model in a sensitivity analysis. In general, the two allocation models show very minor differences in results, except in the case of waste treatments and recycling products. So that's using them together as a sensitivity analysis. It's a good approach. And related to the consequential LCA is aiming at assessing the consequences of a change to a system. So that's the whole perspective. And if you are doing this kind of LCA, then using the consequential system model is, of course, a good idea. This system model is looking at the consequences of small-scale and long-term decisions. So this is taking the constraints that are taken into account are applicable at this scale of time and horizon. So it's looking at changes in capacity, not only changes in capacity utilization, but it's long-term. So it's looking really at changes in capacity. The use of substitution has, of course, major effects on the results of productions with significant byproducts. The modeling of byproducts, as we have seen, creates a demand for primary production and in consequential. So there's a big difference that can appear there. And also consequential uses marginal suppliers. So this might be an improvement, or this might be, of course, more impactful than average suppliers. Another aspect is also that, of course, consequential has much less activities than attributional system models after allocation. So just to finalize, the generation of the database as an undefined system, as an undefined database, as a collection of unallocated uniprocesses, allows the construction of several system models based on the same data. It also allows easier update of supply chains, of course. The construction of a system model, of each system model, I would say, is based on the definition of modeling choices coded in specific linking rules in algorithms. We have 3 system models available for license holders, Cut-Off, APOS, and Consequential. The undefined database is available for consultation for everyone, and it's bounded to license agreements if it wants to be further used, of course. And just a final remark, you have to use the system model that best fits the goal and scope of your study. You have to do a conscious choice of the system model. You have to understand what you're using in order to get meaningful results. We are giving you, and we try to give you the keys to understand the system models, but in the end, it's you who have to decide which one to use for your study. And with that, I would like to thank you very much. And I don't know if we have questions, Dimitra, remaining or not.
Yes, we do have 2 more questions. It's related to the price range that we choose for economic allocation, if it's the last 10 years, for example.
Mm-hmm. Yeah, we try to use an average of the last 5 to 10 years when the products have very prices that fluctuate a lot. So in that case, yes. Otherwise, we might use some shorter averages, the 1 year or 3 years.
Also, another question is related to the level of confidence that we have in identifying marginal suppliers.
Yeah, the database is now, I can use the example of electricity. I think that's a good example. That's also where the more extensive work has been done. And in that case, there's some papers published around it, around how the political boundaries and constraints were considered to establish and determine which were the marginal suppliers for the consequential system model. It has to be said that this has not been done for every single product and market in the database. This has been done first with key products where the change in the suppliers is also driving biggest changes in the database. This is electricity, this is heat, this is some fuels, etc. But it's not done to all products.
And it seems that there are more questions coming. So I don't know if we have more time to...
I think we still have some more minutes, yes. I think we have, the webinar is 1 hour and a half.
So one question is related to the consequential LCA. Mohammed is asking, in case of performing a consequential LCA for the foreground system, should we use the consequential LCI in the background for all our background datasets, or we just need to where we found their structural effects on the background systems?
I will advise strongly here against combining the 3 system models together in the same background database. the system models, they function as a whole. So combining bits of one system model with bits of another system model to construct your background system, it's a very bad idea. So if you're doing a consequential LCA, I would advise you to use the consequential system model. It makes sense. You might want to eventually improve parts of the background database. If they come too close to your foreground system and you want to improve it, you might want to go there. But I would advise against moving parts of cutoff into the consequential or things like that.
And we have one more question. Aspects such as electronic components seem unchanged since the ecoinvent version 1. And what are our plans? Which I think it's a quite good opportunity.
Yes, exactly. So yes, I would say version 2, not to be so mean as to say in version 1, but yet they are definitely they are in need of an update. This is something we are working for version 3.8 to be released in 2021. So we have several ongoing projects there at the level of updating appliances, also components, and also the chemicals that are used for electronics manufacturing, which is also a key aspect of the whole value chain. So we are working on having as much as that for the version 3.8. So something else? We're getting a lot of questions. That's nice. Okay. I would suggest, Dimitra, what do you think? I would suggest that we can maybe finish this for today, and unless you see something coming in that would be nice to take, I would say we say goodbye, and we address the eventual remaining questions via email. I don't know what you will say. You're the one seeing the questions.
So we have already addressed some questions by in the question box. So
great.
Yeah, and the others have already been addressed